Hello everyone and welcome to this masterclass that we are going to talk about design failure mode and effect analysis. Here we are going to share how to master the DFMEA by the 7 steps of the AIAG-VDA format to design excellence. In this masterclass, we are going to unlock all the secrets about this methodology, and I am going to show you how you can master these 7 steps with the aim of reduce any kind of risk, any kind of situation that we are not able to accept. This with the aim of design to the next level of excellence. If you are a product designer, engineering, quality, manufacturing, you are going to consider very interesting this topic because DFMEA is your golden ticket to success. I am going to provide you a complete actionable roadmap about how to use this AIAG-VDA methodology with the 7 steps approach and to improve your products and your customer satisfaction. Stay with me until the end of this basic training. And we are going to learn about this tool. My name is Yeudiel Melgoza. I am subject matter expert in quality management. I have more than 14 years of experience in the automotive industry and 6 years as consultant, providing training in topics as quality management systems, as core tools, and problem solving. So I am happy to teach and I am happy to share my knowledge about this area. In this specific masterclass, more than see topics or all the history about the tool, we are going to review directly what is this DFMEA tool, and first of all, why DFMEA? Probably we can consider that this is just documentation, and this is just because the customer is asking, we need to fill an Excel file or whatever you consider. But no, DFMEA is together with BFMEA, control plan, etc. are tools that are specialized for us to review all the risk mitigation in the process with the aim of ensure the quality of the products as well as the customer satisfaction. The cost of a failure skyrockets once your product hits the customer. It is really critical to have any claim by the customer that the customer finds any kind of rejection or non-conforming material at their facilities because our products. So we need to work in a preventive way to avoid these kind of issues. A strong DFMEA prevents those nightmares before they even start, ensuring designs are safe, are robust, and customer approved. So why DFMEA? These are three main considerations we need to take care: prevent design failures early, improve customer satisfaction, and reduce costs and warranty issues. Um, the IA, AIAG-VDA methodology needs 7 steps for the DFMEA and BFMEA process. In this case, for the DFMEA, we have also the 7 steps, but with different considerations. This approach is well organized into three main stages. The first one, the system analysis. The second one, failure analysis and risk mitigation. And the third one, risk communication. And per each stage, we have the steps. In all these three phases, we are going to understand the system. We are going to analyze all the risk, and finally inform, communicate the results of all of these steps to the top management, etc. So it's crucial to review all of these steps. The first step is the planning and preparation. The second step is structure analysis. The step 3 is function analysis. The step 4 is failure analysis. Later is risk analysis as a step 5. And step 6 is optimization. And finally, we are going to document the results. This is the DFMEA format. These are the steps we are going to review one by one and explain what the definition and what is expected on each step. And let's go for the step number 1, the planning and preparation. This step 1 is all about uh, setting the stage. So we need to define a clear scope. Even the best DFMEA will miss the target if we don't have a clear scope. So it's highly important to define the scope together with the team that is going to work on this analysis and gather all the necessary information to support the engine that powers the study. So in this case, we are going to have basic information regarding the company, engineering location, customer name of the product that we are going to ship, and the model year and platform. Later, we have subject, the DFMEA start date, the DFMEA revision date, as well as the cross-functional team. It is highly important that all the relevant areas participate here. And we have the DFMEA ID number, that is a consecutive number that in each organization can assign, together with design responsibility and confidential level. So here is highly important to involve the management team to set the corresponding scope of the study. So we need to be very careful in this definition to, based on that scope, determine the necessary resources to achieve that analysis. As a second step, we have the structure analysis that here, for example, imagine you are in a new city and you need to review a map. You need to know the neighborhoods, you need to know the streets, the houses, where is located the restaurants, etc. So the structure analysis is similar to a map or is similar to a GPS for your design. It breaks into down logical all the steps of the structure, and in this way you can target the right areas for risk analysis. So the structure analysis is divided by four main um, concepts. The first one is the system. The second one is the subsystem. After that is the assembly, and the last, the components. So we need to review this big picture that is through the system, but and later the subsystem that is a major part of the system. For later review, the assembly that is a smaller unit of the subsystem, and finally a component that is all the subcomponents that consist on this assembly. So with the example of an entire car, a subsystem could be the transmission system, just to say one example, that this transmission system have a gearbox as a assembly, and part of this gearbox we have a specific gear inside the gearbox. So this is how can we can divide by many stages or by many elements of the system. So in this stage also we need this structure analysis to identify and break down the design into these parts or these elements. So it's highly important to have a clear understanding on how we can move forward or how is divided our component. And very important to review that our component we are providing to a customer is part of a major assembly. So we need to review this kind of failure modes based on how potentially could affect the customer. And once we have this structure, we need to review the focus element. Here is highly important to check that the focus is the first system or is the first step in the order of the format is it is indicated by as a second, but is the first point that we need to review. This focus element is what we need to start and later identify the the next lower level of a characteristic type and the next higher level. So this is how this works. And just to confirm, the next higher level is the larger system where the focus element is installed. So this is the reason why we need to define first what is the focus element. Focus element is the specific part, subsystem, or assembly that is going to be analyzed. So once we define the list of all the focus elements, we move forward with the larger system in the next higher level. Finally, the next lower level or characteristic type is the immediate components or features that make up the focus element. So this is how this works. And we need to move to review this consideration of this breakdown for this structure analysis. Why is important the next higher level in the DFMEA? It's important to identify failures not only at the local part but also at the system level. As I mentioned, everything is part of a major system, so it's highly important to review all the potential effects, all the potential failures our part may have. This analysis is not just to consider what, for example, as an isolated part, as a separate part. It's highly important to review everything, the interaction with the counterpart in the vehicles. So it's this is the reason why it's important to detect failure modes that also may not be obvious when looking only at the component itself. This is the reason why we need to take into consideration the major system and to align the design with the customer requirements that focus on the full system performance. So basically, this is everything regarding this focus element and the structure analysis. The third step, function analysis. Here, basically, we need to define function and to define requirements. Think of each part like a player on a soccer team. Every soccer player has any specific role, so it is very important to review what are the responsibilities of each soccer player and what are the expectations from each one. So the function analysis ensures that every player, in this case every component, every subcomponent, every system, sorry, is clearly understood before the game begins. So is the reason why we need to have this function analysis. In this step, we are going to explore what the product should be doing and how that functionality is facilitated. We are going to use the structure analysis that we developed into the step 2, and each element is analyzed separately in terms of its function and corresponding requirements. So let me show you again the whole format. The reason of the colors, gray, blue, and purple, is to have the review or the match per column. So this is aligned with this and with this. This is aligned with this and with this. Purple with purple and purple. So this is how this works. And we need to review to fill this column or to analyze this column to review what we consider here. In this case, this step is divided by these 3 requirements. The first one, the next higher level focus and requirement. Here, the function and requirements that the next higher system expect from the focus element. So this consists this section. Later, the focus element focus and requirement. His is the intended function and performance expectation of the focus element itself. And the third one, the next lower level focus and requirement or characteristic. Here is the specific function or characteristic that the lower level must fulfill to support the focus element. So again, everything starts here, and we need to consider this and this. The step 4 is we build a failure chain linking of how a part could fail, what happens if it does, and what might cause it. Understanding this failure chain is pure goal of risk prevention. I consider this step 4 is the heart of the DFMEA analysis, so it's highly important to review it. And mainly in this stage, we are going to identify failure modes and analyze effect and causes. Here, the concept of failure chain is used to visualize failures as a part of 3 links of a change. We are going to have failure modes, failure cause, and failure effects. So this is the 3 considerations to take care. And a failure mode represents any matter in which an item, in this case the focus element, again we are going to start here, could fail to meet the intended function. So it is highly important to review or to have a clear understanding of what is the intended function or intended purpose of that subcomponent or focus element. A failure mode effect is the consequence of a failure mode. So first we are going to analyze this and later this. A failure cause is an indication of why a failure mode could occur. Okay. And analyzing failures involves identifying how the focus elements detailed during the structure analysis may fail to perform intended functions documented by the function analysis. So basically this is what we are going to analyze. And finally, a failure mode leads to a failure effect triggered by a failure cause. So this second together with the third and later the third. So this is how this works. And determining potential causes is the heart of the DFMEA. So Basically, here in this first column, the failure effects to the next higher level element and our vehicle end user is the impact or the consequence of a failure mode at the system or the user level. I think this is very easy. The severity, this is the rating or is a score of how serious the failure effect will be for the end user or for the system. This column of the failure mode FM is the way in which the focus element could potentially fail to meet its intended function. Finally, the failure cause of the next lower element of characteristic is the root cause or mechanism that could trigger the failure mode. So this is everything for the fourth step. In the step number 5, the risk analysis, we assess every risk with three lenses, with three ways of assessments. How bad is it? How often may it happen? And how likely are we to catch it? So this is what we define in occurrence and detection. This leads us to an action priority that we are going to see in this AP column. And because not all the risk require the same energy, the same resources, so the action priority works as a way to prioritize what is most critical. In this step, the severity, occurrence, and detection of each failure chain is evaluated. An action priority level, here we are going to have three options: high, medium, or low, and this is rated based on the SOD, the severity, occurrence, and detection. Depending on what is indicated on each one is the AP value. This AP value, high, medium, or low, is a standard based on what we score in the severity, occurrence, and detection. And more than establish a risk priority is rather a priority level of action needed to reduce the risk of failure to function as intended. Every potential evaluation combination is assigned as high, medium, or low as informed, and these AP values are standard. So we are going to have tables and in the core tool, and based on that tables, depending of the scores of SOD, we are going to determine the high, medium, or low action priority. For a high level in the AP, action to improve prevention and or detection controls must be taken. Is mandatory. All the ratings, all the failure modes that we are considering as high is mandatory the action, and we need to act immediately. Later, if the AP is medium, an action to improve the or prevent or detect the controls should be taken. Here is a recommended, not with the same criticality as the higher level, but is recommended with a more reduced any potential risk. Finally, if the AP is considered as low, an action to improve prevention and detection controls could be taken. Is not mandatory, is not a recommendation, it's just an observation, just to say in one way. These columns, in the first one, the current prevention control measures already in place to prevent the cause of the failure. So here in this step is what we currently have. The column of the occurrence is a rating of how frequent the failure cause is expected to happen. This based on historical records, etc. And for current detection controls is what we are currently have in place to detect the cause. So prevention is to avoid the creation. Detection is to catch if a problem is created. This is basically the difference between each one. And the detection score is the rating of how the current controls will detect the failure cause. So this is based on the standard tables that is part of the handbook of the DFMEA AIAG-VDA methodology. And finally, the the action priority is the priority ranking based on severity, occurrence, and detection to guide risk reduction efforts. This column that is optional is a filter code. Is just a kind of internal code that is used in your organization to sort or categorize each of the FMEA records. This is optional. In the sixth step, the optimization, it's time to fight back. It's about taking smart actions based on the action priority to make the design stronger, safer, and more resilient. Here, the DFMEA stops being just a document, just a paper, and starts being a real world protection. This is the reason why we need this step. And the primary objective of this step is the optimization to develop action to reduce risk and increase customer satisfaction by improve the product. Most action will involve lowering or the occurrence of failure causes or improving detection controls. Whatever you consider, for sure the ideal situation or the ideal scenario is to avoid the creation, but sometimes to avoid the creation of a failure requires a lot of money or whatever. So, or depending of the nature of the process. So if you are not able to avoid the creation of the failure, please put a control to catch. And either approach leads to a more robust design. This is the reason why we are performing this analysis to create robust designs. In this case, after we analyze in the step 5 the current conditions, we are going to determine the necessary actions in terms of prevention and detection. So these actions are going to be new or improvements over our current conditions or our current actions to eliminate or reduce the risk of the failure mode in terms of prevention and detection. Once we are determining these actions, we are going to define the responsible person's name, that is the accountable person, for completing the assignations or the assigned action. The target completion date, well, this is very easy, is when are we going to expect the implementation of the action. The status is the current progress or condition of each action, open, in progress, closed, etc. Action tagged with pointer to evidence is a record of the actual action implemented along with the reference of supporting evidence. When the completion date, here is a target, here is a real date, and once we implemented again the actions, we are going to assess again the scores for severity, occurrence, and detection. And based on this SOD, we are going to have a new action priority that is basically the same as the previous step. Once again, we have this filter code, an optional stage, and finally a remarks column that in this case is to review any kind of additional comments, clarifications, or notes that you could consider relevant to the analysis. In the seventh step, there is not any specific format to pursue, and it's absolutely necessary. It's really crucial because it's the way you are going to document or to provide evidence of all the analysis. So we are going to finalize the study to put in a Excel file, a Word, a PPT presentation, all a summary of the analysis, the actions to be pursued, and all what we need to review. This is shown to the top management and ensures that lessons learned are kept, not lost. Uh, Here the results should be fully documented and the DFMEA is not considered finalized till this step is performed. Finally, why a DFMEA is a game changer is because risk management is a priority, is proactivity. So if you are correctly managing the risk, you are going to be successful in your process, in your launch, and with your customers. So DFMEA is not just paperwork, it's a full analysis to avoid any kind of risk. Design robustness is equal to customer loyalty. In this case, if your design is really robust, you will avoid any kind of rejection, issue, quality claim, etc. So your customer will be happy with you. And your customer will be, you are going to be the best friend of the customer when it comes to product launch, customer trust, and business growth. So finally, as a consequence, you are going to protect your brand and your reputation. This is the reason why DFMEA is a game changer. How I can help you master DFMEA? I can help you providing you full DFMEA training, hands-on workshop, and templates and mentoring. So again, DFMEA is not just paperwork, it's your shield. It's your company's best friend when it comes to product launches, customer trust, and business growth. So if you have a robust analysis, you will be success. And if you need help, please feel free to contact me. If you want to take your DFMEA skills to a real world professional level, please don't hesitate to contact me. I can help you with hands-on exercise, personalized support, real examples tailored for your industry. So let's make your design unstoppable. Thank you very much for your time. You can follow me on all my social media. Here is my email, my LinkedIn contact, and I was really happy to share with you this knowledge and see you soon.